Okay, here we go. Hello, everybody, and welcome to the first stream actually this year. I hope you can understand me well enough, and I'm happy to be back here on Twitch. Thank you for tuning in. Today, we will go through several topics. First of all, I want to address something that came up both from some LinkedIn followers from mine and actually a colleague of mine. It is about how to visualize free surfaces in WOF simulations. So WOF simulations are simulations where you have a volume of fluids. That is what WOF stands for. And you have basically multi-phase flow. You have presumably air and a liquid, and this is separated by a free surface. I have such a use case just right here in front of me. That's a scene that I have created last year for I guess it was a customer that we did this for. Yes, and I will just open it up right now and we can see where we started. Please bear in mind, this is my very first stream. My home office relocated over since the last stream. I hope I'm not facing any internet connection issues. If there's something wrong technically, please let me know in the chat. Okay? Cool. So, what is this simulation about? We will see once it is opened up. So, as you can tell from the file name, it's a simulation where things are getting mixed. Yeah. And while it's loading, let me just open up my stream as well on my mobile phone just to double check that everything is all right over here. Okay. Seems good. So, while it's opening up, we can do like nothing in between. It says opening scene already. It is a time-dependent simulation, obviously, and it is basically mixing two fluids into each other. Thank you, GeForce, for nothing again. Yeah, will be vanished in a second. So here we go. What's all this should not be our issue. But here we go. That's the scene. You can see there's a mixer in here, which is just mixing our fluids. Because it's an advanced post-processing, I have turned off all the lights. Can turn one on so we can see what a little bit better what this is all about. Okay, let me just show you how it looks right now when we turn on advanced rendering, because that's literally our how it will look in the very end. Let's see. Do I have some interesting background? Cube 1 is our background. Ooh, that's really white, what we are seeing here. Showing that backplane as well. Okay. So here we see we have a dense liquid that we pour into the thinner liquid, and it gets mixed, which is indicated by the volume fraction color map, and it's just a resampled volume that gets mixed around here. And that mixer will turn and spin and mix the fluids all together, while the high density fluid still pours from the top. What we do have here is several displayers that represent certain parts of our representation here. And we have that steel that I have partly shown. We have some glass. We have that tumbler or a mixer device in here with some pins on it. Yeah, fine. So, and then we have some feed. I don't know what that's for. That's a German word for that suction device that sucks out the mixed liquid. It has a rubber lip or something at the bottom. We have an inlet that's right here. And then we have several displayers just for the colored stuff. And yeah, let's see, starting from here. First of all, I'm gonna disable everything that we don't need right now, which is the volume render here and the section in there. And then we have that black ISO surface as well that we are going to disable as well. Okay. Is this one shown right now? Yeah, it is shown. That's our liquid surface. That's like the end result of our stuff. Putting away the glass as well, because that's just in our way, as well as the inlet right here. So that's restore view. Do we have a nice view? Yeah, that's probably a good view that we will keep like all the time. Don't mind my background. Green screen will come sooner or later. So this is just our steel right here. And to take a look what is here, we can first of all put a derived part into this. For example, some plain section for the start. That could go like, what is it? Nope, no, that's the wrong one. Just like that. And we make a new scalar displayer here. So creating that one. So we can at least take a look what's inside here. Oh, you know what? Just deleting stuff that we don't need right now. Bam. Here you go. So we have that section. So to visualize this, we could say, okay, let's do some. We could apply a density here, for example, and just take a look how this looks right here, right now. Turning off the advanced rendering, turning on some light so we can see. Okay, this is what the volume of fluid simulation looks like. So we have something there gets air dragged alongside with the swirl from the inlet that pours down. You can see here we cut through the inlet thick liquid that gets poured from the top, and then we have a free surface right here, right now. Okay, let me just switch that from 16 to 9 to fit screen so we see a little bit more. Okay, and we want to visualize this surface. Normally what people normally do is, I'm just gonna make a group for all the old ones. And so we can start anew. Ah, we don't want to, obviously. So what people typically do is they... Come on, what's loading? Okay, I'm just gonna open a new scene, but first of all, I will work on the derived parts, because that was the issue just right now. New group, saying old ones, just putting them all into there. So making a new empty scene, and for that empty scene I'm gonna put, what am I gonna put? Gonna put some things from here, there. So like these ones will go here. Come on. Okay. Here we go. That's our empty bin. So we want to visualize the free surface right now. So what people typically do is they say, okay, gonna do an iso surface right now, right here, and say scalar, it's let's scroll a bit down. What do we have here? We could of course make a density function. Well, let's start with that. So we can go with density and then say, okay, the average is something, that's yeah, 700 kilograms per cubic meter is reasonable. Create a displayer for that, and here we go. Ta-da! We have a liquid surface. And now we say, okay, it's, yeah, like that. It is what it is. Let's enable advanced rendering and see how it looks. Yeah. So how is it? Yeah, looks interesting, but let's make it look a bit realistic. So we first enable shadows for that one. So things are getting dark down here, or maybe not. And the non-physical appearance is scrapped, so we go to matte, and then because it's should look like a liquid, we apply some clear coat on here, and we have something interesting. Yeah. Bear in mind, reflections only look as good as the things that get reflected. So to have something that can get reflected, we are using an environment map for now. So the environment map, do we have something? Yeah, someday I should bring some interesting backgrounds to this workstation as well. So here we have some factory outside, and we can look at the surface and we can see, okay, it looks okay-ish for a starting point, but we realize something. There is something like a ring just right here. And this is because we are not simulating a single region, but we have two regions. We have that mixer region, that's just the inner volume, where it is rotating. And then we have a tank domain that's rotating in another direction, and that suction device is in there. And that leads to these, I call them artifacts. I don't know how to say it any better, but this is physically correct, but just looks suboptimal, so to say. You always see this in marine applications as well. When you have a boat that's going full speed, you typically have an overset that's going with the boat, and then you have the free ocean that's simulated in another region. Yeah. And at the edges, you see exactly that. And it might even look worse if you say, okay, that's not a matte displayer with something that's looks like blue wall color. If you say, okay, let's take another color when it's green. Ooh, that looks interesting. Just trying to. Wow, that's really, really most impressive. Okay, when I turn it dark, yeah, you can see the highlighted reflection. So I guess that's some quite good for now. But when you turn, instead of matte material for a color, if you turn it to transparent, yeah, you instantly see nothing. It's too dark, maybe. Let's make it brighter. Okay, that looks, I don't like it. Transparent is maybe not the right thing. So for water, you could enter the index of refraction, which is 1.333. That's actually physical properties of the visualization. Doesn't make it any better. When the rendering is finished, it will definitely look some kind of nice physical behavior here. Ooh, but my quality options are really bad. If you want to clip something, that might be not the right point to do so, because now I'm showing my standard visualization properties for all time. So quality is 0.5 and noise reduction is 0.5. My boss tends to make it higher. I tend to make it lower because, yeah, I will talk about that later. And this one is 1/400. Yeah. So what is this about? Quality is a logarithmic scale between the min and max render samples down here. And noise reduction is just, yeah, okay, I'm see that one here is quite noisy, but in the end it will make another noise reduction and it gets less blurry. But on the other hand, lighting effects are reduced by this as well. That's kind of the back side. Yeah, that's not the good option. But I keep it always like that. So where was I? So transparent, we have that. We could also go for transparent body. And with that, we get an index of refraction that we turn to water again at that point. We could also see that that mixer really looks underwater right now. I like it better already than the clear, the transparent one. We could also add some roughness. What this will do, I will show after this rendering has finished. For marine applications, I would always choose like here, that transparent body. If you want to add some roughness, that goes here, but please bear in mind that this could show some logarithmic behavior as well, because adding the roughness will probably, yeah, you add a tiny amount of roughness and it gets quite rough instantly. Yeah, you can see it doesn't look too good. Yeah, it doesn't look like water anymore when it's rough. But for other options, if you don't want to see perfectly through glass, that's a good and viable option. So let's turn it back to 0 for our purposes. Or shall we wait until it's finished? Yeah, another 16 seconds. Here we go. Yeah, you can see it gets really gets mad if you put this at 0.1. So let's turn it back to this, and we will go back to matte for now because I want to highlight something. Oh, it was orange. I didn't even notice. I thought it was solid red. So first of all, we want to get rid of these artifacts. And to get rid of these artifacts, there are several options. One could be, you can even see these artifacts when you disable advanced rendering because they are just here. See? Yeah. One option could be, so let's store this as our first one. So the next option could be you make a this was an isosurface. We could do it with a threshold, and this will be horrible. So doing density here again. Yep. And say all above 700. And then create a new. Yeah, that's horrible. You can instantly believe me. That's because that is just every cell displayed that has more than 700 kilograms per cubic meter density. Yeah, looks like horrible. Don't do this. Okay, so next up, instantly deleting that one. Next up is the resampled volume. And the resampled volume is something which just takes the whole domain and, yeah, as it says, it resamples it. So let's check. 4.1 million cells will be there. That's okay for me. So make no displayer for now. Creating it and closing it. So now we take this resampled volume and drag it over here and say, can we put it into a surface? Wow, we can. Yeah, but it doesn't help. Okay, that's crap. We delete it. Typically, you put it into a scalar. And then you select a function. Where are my color maps? So here's Siemens color map for first of all. And then we select density again. Okay. So this looks like that. It's a solid volume that's just filled with kinda smoke. Yeah. And now you can go for your scalar and say resampled volume settings. You have a rendering mode which says volume right now. You could use it for several purposes. For example, marine applications. You can use it for your water depth to have your deep water turning dark blue. So if you say, okay, transparent, going darker, that's how you blur away that you just simulated the surface. So here you can say, okay, we are going for an ISO surface at that point. So you say, yes, single surface, please. And then you say, okay, come on, 700 kilograms. And look at this. There is no such thing as these artifacts. Okay? It's all in one. It's because it takes the data and resamples it into the volume. Crazy. Minor drawback, you can't select you cannot directly select preset materials right now. So it gets kinda complicated to apply visual effects at that point. But we will make it. So what's happening when we turn on advanced rendering? It looks like crap again. So we go for a matte display right here, right now. And say, okay, 0.5 was our clear code. You could also say, yeah, we are doing something different here, like 1.33, because that's an index of refraction. Yeah, but we're not doing it right now, right here. And of course we need some shadows. Sad though, it doesn't look as if this is really a matte display. It still looks unphysical to me, if you ask me. Okay. We are done here. So let's see what happens if I say, okay, please go for transparent body. Yeah, it doesn't help. It is just because the resampled volume doesn't support these effects. So what do we do? We take this and combine these two methods. So we put this one away and we say, okay, make a nice new ISO surface, pasting it here. And instead of putting the tank into, we say, please go for the derived parts and take the resampled volume in there. Then check and make a new surface displayer. Did it work? Did it work? Did it work? Why don't I see anything? Well, that doesn't work. That's good. That works. That doesn't. Damn. So let's see. What did we have in the old one? So the liquid surface is a surface displayer right here. And it's liquid surface 3. So let's take a look at liquid surface 3. this is a threshold. Yeah, it's not an isosurface. It is a threshold where the resampled volume goes in. Yeah? I guess the resampled volume is what made my simulation crash last time. Not sure who made these properties, but maybe we can cancel it. Okay. While we are waiting for this, come on, do your job. It's, yeah. So, it's a, what did I do now? Okay, it's a threshold of several things. So first of all, we need, yeah, exactly. We need an isosurface, and so it's actually an iso. Just a second. So here goes liquid surface 2, and liquid surface 2. Liquid surface copy goes into that. And that's resampled volume 2. So first of all, we need a resampled volume. We do have that. Okay? Resampled volume. Then we have that isosurface. We're not taking density here. We are taking, I guess it was volume fraction. So let's go for volume fraction of G, whatever this means. Can we please? No, it's not showing. Why isn't it showing? Damn. Can delete that. What did I do wrong at that point? Liquid surface 2, liquid surface copy, resampled volume. So I'm just gonna copy this one here into our, so here we go. That's a resampled volume that goes into the isosurface, and it's a single isosurface. So we put it over and take a look at it. So come on. Here we go. So this one can be deleted. Yeah, nice. And this is how it looks. And now we can apply surface effects if we want to. So turning on this one. And now we are just copy pasting the isosurface properties, which means we are going for constant. Then we can drag and drop the color down. No, we can't. Damn. We're going for orange again. Orange. And can we drag this one down? Yes, we can. Well, you can copy paste the effects from up to down here just by dragging it down. So here we go. We have that orange surface. But sadly, we got us some new artifacts. We deleted the old ones and we got some new ones. But the surface here, that's nicely closed. And if it's not, you can just increase the render density of the resampled volume. So what do we do to get these away? Well, we do a threshold and cut them off. If you have a marine application and just have a free surface, that's not an issue. You will just have one surface that's going through, and this is how you get rid of those artifacts in the middle. So resampled volume, volume fraction, but the input part is not the two regions. The input part is a resampled volume of the two regions. One resampled volume where both regions go into. And this is how you make a really nice and shiny surface. And if you want to, you can now say, okay, it's no longer matte. It will be transparent body. Yeah, that's what I'm talking about. That's what I'm talking about. That's how it should look. Better than I expected, to be honest. Okay. Any questions on visualizing free surfaces? Just hack them into the chat. And I'm happy to give my best to answer them.